In the world of manufacturing, tension equals stress. In this lesson, we're going to show you how to properly add bend reliefs to your design. So let's get into it. In the last lesson, we talked about how the bend deformation directly affects the features that are around it. In this one, we're going to talk about how it affects the corners and the edges of our bends. Now, what do I mean by that? On the board here, I have two main situations drawn up. I have one in which a flange sits along a line in which it doesn't do the whole entire bend length. The other situation is where I have two corners that are adjacent to each other in which two bends are making a corner here. So let's approach these completely separate. In the first one, we're going to talk about this as a bend relief, just a standard bend relief. Now, why do we actually need to remove this area? Well, when we create that bend, and we've talked about it several times now, is we cause tension and we cause stress, and that stress can result to cracking and tearing. We're essentially creating what's called stress risers in this part, and we need to get rid of that stress so that we have a good long-term part. First thing though, is that you can bend this part just as is. What you're going to see though in the long run is you're going to see cracking that happens from these corners here. And that's because of that stress riser that we're putting into the part. You might not see it during the manufacturing process, and you might not see it for a little bit after you install the part, but eventually, especially if there's any vibration in this, you're going to see cracks and some failure in these. So how do we make that a little bit more robust and also cleaner for the manufacturing process? Well, we add what's called a bend relief. Essentially, these are just slots that we cut into the part that essentially get rid of that deformation area and allow you to separate this part of our flange from the area in which needs to be stretched. Now, this is just simple, it's just a slot that we're cutting into it, and there's a rule of thumb that you can follow that makes it so that both the manufacturing guys on a press brake operation are going to be happy with you, as well as the final parts will still look cosmetically good. Now, the width should be about 50% of the material thickness. This is a rule of thumb. You can go a little less or a little more. And if you go a little less, it gets a little bit tighter for the manufacturing process. They might have a little bit of kickback there. But generally speaking, this is going to give you enough stress relief back here in these radiuses to get the job done. Depth-wise, so when we started talking about our depth, is how far do I need to have that slot go into the part to the outside of our tangent radius there? Well, we want it to be the bend radius plus the material thickness plus about 20 thousandths of an inch. Now, again, these are all rules of thumb. If you need it to be a little bit tighter, you can be. You just might start seeing that deformation, or you also might see those cracks and stress coming through the part later on. So you can play that a little bit loose and fast, but the overall idea is that we're trying to just relieve that stress in this corner here so we don't end up seeing any cracking. So now that we understand that when we have this situation, and we can change this design so that even if it was all the way up to this corner here and that bend radius came down, we still need to relieve this corner, right? So those situations can be manipulated and changed over time. Just anytime you see that, you're going to end up getting that stress riser. All right, on to the second problem that we're trying to relieve. When we have two corners like this, we're going to end up seeing a ton of deformation in this. We have essentially doubled the deformation between these two. And this situation right here is actually almost impossible to manufacture because we are going to end up having a radius that comes in to the part in which our punch and our die are not going to be able to sit in this. We have like an overlapped area in which we need to apply the bend. So how do we fix that? How do we relieve this stress? Well, we can do it in two different ways. We can essentially put a round circle where you can kind of think of that center line kind of coming into it. We punch a round circle into it, which it has a certain distance that relieves those stress, or we can have a square. Really in the end, cosmetically speaking, it's what is up to you on what you want to have the final part look like, as well as if you're going to be welding it later on. Sometimes the square ones are a little bit easier to weld. This one also has a rule of thumb with it, which is just from the center line to the outside. So that measurement there is going to be the material thickness minus the bend deduction divided in half, and then plus about 15 thousandths of an inch. So that particular equation right there is a little bit more complex. On these, typically when you're in a good CAD software like Fusion or SolidWorks, they're going to automatically apply these bend reliefs into the corners for you. With this one being said though, is if you don't do this, I'm going to go back and just reiterate one more time. What you're going to see here is most likely an unmanufacturable part. And if they are able to manufacture it, you're going to see a ton of deformation in what we call dimpling. And so we can actually, it rolls up in the corners and creates this big tower there. It hurts your fitment, and you're also going to see major cracking in this corner later on. So now that we understand why bend reliefs need to be put into our parts, it's finally time to get back into CAD, and we're going to go through everything that we just learned in bending, show you where it's at and how to manipulate it. So we'll see you on the next one.